My name is Michael Weber. I'm a professor of mechanical engineering. Good to see all of you here at UT Energy Week, which is, I think, a huge success. So many congratulations to the whole team that organized and pulled together. It's my honor and pleasure to introduce my good friend Nicole Iseppi here from the Bezos Earth Fund. She and I worked together in Paris, first met 5.5 years ago. We're executives together at Engie, and would find a lot of solace in each other as two of the non-fluent in French executives at a French company. So we would get together to go over our trauma and therapy together on this, which is really great. Nicole's fantastic in many ways, a lot of experience in the world, lived in Japan, lived in Dubai, lived in London, lived in Paris, and now in Washington, D.C., all in the world of business and finance and banking for a while at JBIC, Japan Bank Investment Corporation, and then at Engie, and now at the Bezos Earth Fund running their energy program, and she'll tell you a little bit about that. But also a lot of advisory positions and board positions at IRENA, the International Renewable Energy Association, the Terawatt Initiative, the GAP, the Global Energy Alliance for People and Planet. So just a lot of things with a multinational view in the energy world, and now with a philanthropic lens. So really glad that she could be here on campus with us. She and her colleague Charlene's here are exploring UT and learning about all the great things we do on energy. So hopefully we can get them back on campus sometime soon. But I hope you'll join me in welcoming Nicole Iseppi.
Thanks so much, Michael, and thanks so much, UT, for welcoming Charlene and I here this week. It's a real pleasure to be here in Austin and at UT. Let me get this sorted. There we go. Oh. All right, I think that will do. So we're really excited to be here today, but the connection between what each of you're doing and what we're doing represents a convergence of creativity, innovation, passion, and boundless potential united by a common purpose, and that is, how do we accelerate the clean energy transition? Our gathering today to explore the power of innovation in the realm of clean energy with students and entrepreneurs who are at the forefront of creating and scaling up solutions is a huge opportunity to catalyse transformation action. Aligned with this mission of spurring innovation, we at the Bezos Earth Fund, we focus on driving progress in fighting climate change and protecting nature through systematic change transformation. Actions that will help us move closer to a more equitable and sustainable future. Bezos Earth Fund is focused on accelerating action in this decisive decade, achieving net zero emissions and embracing nature-positive development, while also focusing on reducing poverty and safeguarding vulnerable populations will require change across entire systems. These transformations will be powered by emerging technologies, shifts in governmental policies and corporate practices, active engagement from citizens, and innovative perspectives on the future. We are committed to explore innovative ways to de-risk and demonstrate solutions with a potential for systems change. Our role as philanthropy, so we focus on 100% grant making, is to provide flexible capital in the form of grants where risks exceed tolerance of conventional investors. Bezos Earth Fund is proud to provide also to the whole industry and to its various stakeholders in the ecosystem the Systems Change Lab, which helps to monitor more than 70 shifts and enablers for transformation and actively promote a change alongside our partners, alliances, and working together for a better way forward. A core shift for us is to transform the power system, where we will need to implement diverse solutions, including scaling up renewables, deploying energy-efficient technologies, and designing systems to better manage electricity while making sure we create jobs and bring more affordable electricity to all. At the core of our strategy lie certain principles that support innovation. We envisage long-term transformational changes. Instead of quick fixes, we invest in and are interested in initiatives that have the potential to create enduring impact. We identify and address market gaps. We step in to address needs that the market cannot fulfill effectively, whether it's lack of access to clean energy, agricultural practices, or resilient infrastructure. We step in to fill those voids through collaboration and partnership with others. We also build a sustainable legacy. Our goal is not just to provide short-term solutions, but to leave a sustainable legacy that extends far beyond our direct involvement and our hope to benefit future generations. And finally, we're focused on accelerating impact. By nurturing relationships, supporting emerging players, we can scale up impact initiatives. Now, in our pursuit of uplifting initiatives and innovations, I'd like to emphasise and share some thoughts, some factors that I think have the potential to significantly enhance your endeavours as innovators. This is not a complete list, but these are some things that I think you should consider, and we as an ecosystem. First, we need to nurture catalytic and innovative funding models that can accelerate breakthroughs. From early stage project support, such as philanthropic investments, these funding mechanisms can fuel the development and scale up the transformation of energy solutions. We should also emphasise the critical importance of foundational research and development. It is crucial for laying the groundwork for advancements that have the potential to reshape our entire industries. Through funding high-risk scientific breakthroughs that are often far from market, hold the potential to catalyse transformative solutions. And you here and UT have an important role in that. We should also transition from pilot to scale. The valley of death, where pilots succeed but lack finance to scale full commercialisation. Philanthropy capital and others should increase in providing critical validation to crowd in investors. We should also optimise synergies across systems components. Entrepreneurs and whole industries must recognise the interdependencies and feedback loops within the energy system, but also with the ones such as other industry, agriculture, transport, crucially forging partnerships including policymakers, investors, businesses and community leaders all play a pivotal role to understand the needs and constraints to unlock finance. We need to incentivise agile, responsive and inclusive clean technology models that can deliver and respond to disruption across value chains, address contextual social economic demands and market perception risks that also align with the priorities and aspirations of local communities. We need to embrace social entrepreneurship, a new wave of innovation that has social and environmental goals embedded at its core, which can also support the advancement of sustainable development goals within the planetary boundaries. Investing in grassroots innovators. This needs increased support, who are closer to local challenges. These innovators possess unique insights, able to influence culturally, resonate clean energy solutions tailored to the specific needs of their communities. This can allow us to drive inclusive and sustainable progress within the energy sector. We also need to develop and leverage digital public goods, such as the Systems Change Lab I referred to earlier, with access to open source energy data that can influence innovation, but be backed by scientific proof data. The development of other open access platforms can empower researchers, entrepreneurs and developers to explore new ideas, create novel solutions and collaborate. We also, very importantly, need to build the future workforce. Workforce development plays a crucial role in the success and growth of startups, particularly in the clean energy industry, where specialised skills and expertise are in high demand, currently causing skills shortages. By investing, for example, in specialised skills training, collaborating with educational institutions, and developing apprenticeship programs, startups can build a qualified workforce that drives innovation. I also, with this great opportunity of being here at UT and at UT Energy Week, I'd like to also make a very important comment about the role of universities. Universities have a very important role in accelerating climate change action through innovation. As we stand here today with one of the most prestigious universities in the US, I'd like to employ the example of universities as a dynamic ecosystem where innovation thrives. With multidisciplinary perspectives, research, and creative spaces, universities are uniquely positioned to drive climate action. Universities play a pivotal role in testing, validating, and scaling clean energy solutions in the real-world settings. As a member of also a university board, I have also seen firsthand, through partnership with industry, how governments actually can show, how universities can show solutions and accelerate them to industry and to implementation. Whether it's experimenting with renewable energy systems, implementing clean transportation options, creating solutions to advance decarbonisation in hard-to-abate sectors, or optimising energy management, universities serve as living laboratories for accelerating the energy transition. The campuses are not just academic environments, they are actually society ecosystems. They present a unique opportunity to showcase and test innovative low-carbon energy solutions. The insights gained from these experiments on university with students, with professors and local businesses and other stakeholders serve not only for the university community, but also contribute to a broader effect to combat climate change. Universities also play a crucial role in nurturing a culture of innovation among students, faculty and staff. They can serve as incubators for the next generation of clean tech entrepreneurs through startup accelerators and collaboration with industry partners. Universities empower students, researchers to translate their ideas into viable business models. By leveraging their resources, expertise and influence, universities can drive meaningful change, both within the campus and beyond. They serve as beacons of radical transformations and pave the way for other institutions to follow. So in my concluding comments, I would like to say today that as we embark on this journey towards a sustainable energy future, we must recognise the relevance of coming together, pooling our resources, shaping our knowledge and our expertise. Whether you're a student conducting groundbreaking research or exploring new waves of innovation, or an energy startup pushing the boundaries of what is possible, collaboration amplifies the impact we can have to accelerate progress. By working together, we can leverage each other's strengths, overcome challenges, and create innovative solutions that can usher in a new energy era. I think it's important that we also remember we're not just here to discuss innovative strategies. We are also here individually and collectively to drive real change and accelerate the clean energy transformation towards a sustainable energy future. By embracing collaboration and a steadfast commitment to system change, we can unleash the full potential of clean energy solutions and pave the way for other innovators to follow. Each of you have the power to drive positive change, whether through leading a startup that develops clean energy solutions or by contributing to your skills and expertise to an existing venture. As you embark on different pathways, bear in mind that the challenges we face are great, but so too are the opportunities. By harnessing your creativity, your passion and determination, including resilience at times, you can be catalysts for transformation in the clean energy sector. I thank you kindly for inviting us, for the warm welcome to the campus and as a guest for today, and I look forward to meeting you a bit later during the drinks. Thank you.
Okay, how is everyone doing this evening? So my name is Coleman White. I am a student here at the University of Texas, and I am also the co-founder of Verified Carbon, and we are direct air capture developers in the West Texas area. So before I introduce this great panel that we have planned, I want to take a moment to recognize all of the hardworking people that put on this event. They worked many nights, countless hours to put this on, to bring a bunch of people that love energy together. So if we could give a round of applause for them. Okay, so without further ado, I would like to introduce our first speaker, Joselyn Lai. She is the co-founder of Bedrock Energy, and it is a company that is revolutionizing the way we heat and cool buildings. So please give a warm welcome to Joselyn Lai.
Hi, everyone. Thanks so much for coming out today, and thank you for the organizers of this event. Really appreciate the opportunity to come speak about startup innovation here at UT Energy Week. All right, let's see. I did have slides, but I'm happy to go without. So an introduction to who we are at Bedrock Energy. We are a startup that is based here in Austin. And what we focus on is the fact that heating and cooling of the built environment is one of the largest contributors to climate change. And it's also one of the largest draws of power in our cities. In fact, about 50% of energy use in the built environment is typically going to the heating and cooling of space and water. In the face of this reality of the incredible energy needs as well as large carbon footprint of buildings, we actually have something that has been well established in human society for many, many centuries, which is the fact that the first kilometer, the first several hundred, couple thousand feet of the Earth's subsurface provides 24/7 renewable heating and cooling. And the reason is, you can see on the left, there is an incredibly temperate temperature gradient of about 55 to 80 degrees, depending on where you are in the world, in those first 1,000 to 2,000 feet. And this provides an unceasing, always-on heat sink, if you're air conditioning, or heat source, if you're heating, pretty much in any city on the planet. The benefit of this source of renewable heating and cooling is that it has an incredibly scalable and efficient, resilient benefit on what you might call both sides of the meter. Behind the meter, it's in the building, in front of the meter, on the grid. And so the savings that this direct use of free heating and cooling to buildings provides to real estate owners or to low temperature industrial facilities could be in the United States alone $200 billion a year. And that's just behind the meter. On the other side of the meter, which is the grid, over the next 20 years, as society electrifies, the Department of Energy has estimated what you see in the middle and on the right, which is that utilizing direct geothermal for the heating and cooling of buildings can reduce the power capacity needed for the peak power demands for space heating and cooling by about 400 gigawatts. And this is really critical because the construction of new generation capacity and new transmission is one of the biggest challenges to the grid in the United States. And on the third point, the decarbonization of all this heating and cooling, either to electricity and drawing the heat from the ground, can reduce Scope 1 emissions by over 4 gigatons in the US alone. So all of those benefits have been really well established for many decades, whether they be to the grid, to emissions, to comfort and even aesthetics on the building, and just overall being a stabler and easier to maintain form of heating and cooling than conventional HVAC. The problem is, over the past many decades, it's actually been really difficult to install these systems, and it hasn't really scaled beyond universities, campuses like Google, military bases, and it's because of 4 key constraints to scale. The first is upfront cost, oftentimes driving 20, 30-year payback periods, which is fine if you're Princeton or Google or the US military, but not so fine if you're a typical real estate owner. The second is a large installation footprint. The third is the construction time, which can push back schedule, which drives costs for real estate developers. And the final item is performance risk, because the conventional water well drillers who do these systems are very blind about the data regarding the underground energy conditions. In contrast to those constraints in the past many decades of this industry, Bedrock is building an integrated, intelligent design construction platform, full stack, that builds geofields for geothermal heating and cooling in any subsurface conditions and does it fast and deep in order to reduce those 4 barriers: cost, space, time, and risk. And we're doing this and moving quickly in large part because we have combined oil and gas industry expertise, Silicon Valley, and as well as real estate in a multidisciplinary team that brings together all the diverse industry perspectives that help us build something that is user-friendly, customer-centric for scaling up a distributed renewable energy asset class in cities anywhere in the world. So that's the overview of Bedrock. I was also asked, because there might be students in the audience or folks who are coming to the startup showcase because of an interest in pursuing an energy startup career path, I was asked to give some comments on what are some learnings that I might want to impart upon anyone who is interested in a career path in the startup world. And I think if I were to hone in on 2 key takeaways from this journey building Bedrock Energy. The first is somewhat represented by this slide here, which is all the different logos that we have on the screen, which is that in the energy space, innovation is not about bits and bytes, as so much of the past 20 years of Silicon Valley has been. But it's really about atoms and electrons, it's about physical hardware, and it's incredibly multidisciplinary. And so one of the key takeaways that I would bring today is that collaborating across disciplines, having diversity of skill sets, diversity of perspectives, diversity of industry experience is incredibly critical to adoption of any innovation that we want to have an impact in the real world. And in our case, it's the built environment, but whether that be distributed energy or large infrastructure projects, nothing happens without really grappling with the things that can go wrong, Murphy's Law, that applies in anything related to physical innovations and physical installations. The second thing that I would bring as a takeaway is that oftentimes, I'm not sure how many folks here are students, grad students, or undergrads. I often get asked by grad students and undergrads, I want to go into energy, I want to work in climate, and they say, what is the number one thing that I can do to have an impact on the climate? And they want to, do a market sizing matrix on the absolute biggest thing that will have the biggest gigaton impact in climate. And if I were to, I suppose, gently push back on that for any students here who are interested, I would say that the answer is not really about looking outside and seeing like what's the number one, the largest gigaton impact that I could have, but rather it's very introspective about figuring out what you would want to wake up every single day and work 90 to 100 hours a week thinking about all the time, because that's the only way that innovation can really happen. If there are really smart people who are really passionate about a particular nerdy topic, whether you happen to care a lot about the grid or you happen to care a lot about molecules, that's actually really different person to person. And that is so much more important in selecting an energy path than figuring out what might be, the biggest, impact on numerical value. So that's kind of something that I would leave with any students here today. I'm happy to speak more with anybody about geothermal, about the built environment and decarbonization of buildings, or about that topic. Thank you so much for the opportunity to share.
Can we get another round of applause for that fantastic presentation? Okay, next up, I want to give a warm welcome to Aaron Fitzgerald. He is the co-founder and CEO of Mars Material, and what they are doing is putting carbon in everyday products, from carbon fiber all the way to carpet, which fantastic.
Thank you, Coleman, and the UT Energy Commission for having me here today. I actually don't know the host of it, so excuse me for getting the name wrong. So I'm Aaron Fitzgerald. I'm the CEO and co-founder of Mars Materials, and we are working to turn everyday products into carbon sinks. We are doing that by commercializing process technology developed by the National Renewable Energy Laboratory, also called NREL, that enables us to make acrylonitrile. If you're not familiar with acrylonitrile, it's a $14 billion chemical market, and it's used in products that we all know and love every day, really foundational to our society. From flocculants for water treatment and paper pulp manufacturing, to comonomers and polymers for carpets, keyboard keys, vacuum parts, car parts, and all the way to carbon fiber, where we see exceptional growth potential and impact potential. So I was asked to talk a little bit about my founder journey and how we got here. So we're currently a team of 8 working to scale up this carbon negative process for acrylonitrile production. My background, I'm a 3-time founder. I became an expert in carbon removal after joining a group called Carbon 180, which is a DC-based think tank focused on creating the carbon economy. It was during that time that I met my co-founder, Christian, who's a chemical engineer, and he and I set out to identify processes that we could commercialize that would make Mars be a company that could abate 1 billion tons of captured CO2 from the atmosphere. He and I created a market-focused technology discovery framework that was meant to identify process technologies that we could commercialize. In total, we looked at 18 of them from the various national labs and selected the technology that I'll present to you in a bit. We selected the technology because of its market potential and its impact potential. And then since then, we've been so fortunate to build a team of chemical engineers with PhDs, expertise in chemical processing scale-up and operations to advance our company and our process. So if you haven't heard of acrylonitrile, it's a large market. It's anticipated that each of us consume about 1 kilogram of it per year, but it's a hugely emissions-intensive chemical to make. And the emissions intensity of it is only growing. We're talking about nearly 3 to 4 units of CO2 are emitted if it's produced in the US or in Europe, but the chemicals market is actually moving towards China. And there, the emissions intensity goes up to about 10 units of CO2 emitted per unit of acrylonitrile produced. And that's mostly because in the US and in Europe, the feedstock for creating propylene, which is the common route to produce acrylonitrile, is crude oil, and in China, it's coal. And what we're learning, though, is that in markets like acrylamide for flocculant manufacturing and carbon fiber, there's exceptional need to decarbonize today. So these manufacturers are willing to work with startups on a process to scale up technology that can help them reduce their carbon intensity. And that's because it's impacting, in these particular markets where acrylonitriles are sole raw material, the only method for them to decarbonize is to change their feedstock. When you don't have any other options, you have to invest in it. And that's because it's impacting their cost of capital, which impedes their growth plans, and overall is leading to a shortage of actual supply in the market. So we have the only commercially validated carbon negative approach towards the production of acrylonitrile. Our process works by taking captured CO2, water, and electricity. We're able to convert it into any 3-carbon compound that's an ester or acid, and then using a proprietary catalyst that we're developing, along with ammonia, and that C3 intermediary, we're able to convert it into high purity acrylonitrile. And it's a drop-in replacement. And we see a large market for this. Today, there's a growing low carbon demand and a low carbon market for acrylonitrile. And as we are able to scale up and enter into new markets, we see exceptional growth potential. So what has made our company unique is that we have really defined our plans for scale up from day one. We created a 4-phase technology development and commercialization roadmap that has enabled us to create various inflection points at various phases that are all stage gated to advance our process and our technology. We recently completed phase 1 about a year ago, where we produced a little over 100 milliliters of our material for our beachhead customers in the acrylamide industry. Those global manufacturers were then able to validate our material as a drop-in, and we were able to advance into the next phase of supplier validation, which is at the kilogram scale. And then since then, we've really strengthened our foundation, which is really around leveraging partnerships to advance our mission. So with the Breakthrough Energy Fellows Program, we've been able to design and fabricate and commission our pilot facility in phase 2, which enables us to produce about 1 kilogram a day of our material. We're recently completed siting activities and have based our operations over at Shell's Technology Center in Houston to complete this work. We're now moving through phase 2, which is our pilot operations, and collecting the data that we need and finishing our supplier validation so that we can design and site our demonstration plant in phase 3. Then ultimately, we'll get to that commercial scale, which is about 50 kilotons per year capacity in our phase 4 work. So in the last couple of minutes that I have, I mentioned partnerships are really important to us. The two that come top of mind today and are really enabling us to move forward with our goals and our vision is our partnership with Breakthrough Energy, which is Bill Gates's kind of climate investment arm. They've invested in over 100 companies, all with gigaton scale emissions reductions impact. It's really focused on helping to transform the energy space. And then Shell. Most people wonder, how does a large entity tend to partner with a startup like ours? And a lot of it is really setting the right bounds and understanding what it is that the capabilities that we're missing that Shell can help provide. So in our relationship with Shell, we're a tenant on their campus. And as part of that relationship, they've been able to provide us with their health and safety management program. We handle some pretty challenging chemicals that can also be carcinogenic, so we want to make sure that our team is safe. So having the infrastructure that they've set out for 100 years has really helped us. And then in addition to that, we're able to tap into their scale and reach. So being able to leverage their existing supply chain and logistics infrastructure to ship our materials internationally, and to tap into their existing negotiated procurement rates to save cost on input costs. For example, we've saved 300% on quoted inputs on some of our solvents by being able to tap into them. These are not opportunities that startups typically get, And we've been able to be successful by identifying strategic fits and then working with these folks and showing and proving. So with that, I'll end my conversation and looking forward to the happy hour afterwards and happy to answer any additional questions that may arise. So thank you all for having me.
Please keep it going for Aaron. Okay, next up on the agenda, I would like to introduce Jhana Porter, the founder and CEO of Frakktal, a company that is changing the way that we're looking at building materials. Please give a warm welcome for Jhana.
Hi, I'm Jhana Porter, founder and CEO of Frakktal. I want to do like a quick question. $5 Venmo, I don't have any cash. Who knows what this is a picture of? Can you see that? You got to raise your hand, Dave. It is. So did you guys hear him? So this is the train derailment in East Palestine, Ohio, that was carrying vinyl chloride monomer, which is the precursor to polyvinyl chloride. Frakktal is a materials company, and we are developing plant-based materials to transition away from polyvinyl chloride, especially in the built environment. Just so you know, I'm not sure how familiar you are with polyvinyl chloride and what it does, but it has a very complex supply chain. A lot of the vinyl chloride monomers that end up on rail cars like this are created in the Uyghur region of China, and they are created under slave labor. And the United States has kept that at the border because it is created through slave labor. So when you're at home and you're touching your cabinets or your piping or your windows, think of the possibilities that some of these things, people made these materials under duress, and how important it is for us to transition away from things like this. So 70% of the polyvinyl chloride that is made for the built environment. And like I mentioned, some of that is conduit material. So most people think of PVC, they think of what is under your toilet, waste and water streams, but it's also flooring, windows, paneling, fencing, roofing, cabinetry, shingles, everything in your house. This is about 40 million tons a year annually across the world. If you haven't heard about what is going on sort of in the larger spectrum of this, polyvinyl chloride is harmful. And in the last 3 months or so, the EPA has cited 5 chemicals that they are looking to put under review. If you're familiar with what that review process looks like, this is what happens right before a ban, right? So vinyl chloride monomer, which was in those tankers, is part of that review. And what that means, what that potentially could mean, is that there's a ban on this, and all of the products that you currently use would have to be made with something else. So the question is right now, what are we doing in this space, in this time, to move away from that, as we have already identified that this is problematic? So there's an EPA quote that's passed around a lot, that people in the United States spend 90% of their time indoors. And if you're spending 90% of your time indoors, think about the walls. Some of these are wood paneling, but the carpet, the matrix underneath the carpet, the things underneath your seat, all those things are made from polyvinyl chloride. And you think about what that does to your endocrine system, the microplastics, all of those things are interacting with your body in ways that you probably don't know. And it should be something that you think about. So this is what we did. We have made a plant-based, it's something that you could probably eat if you want to taste it. I have some in my backpack. I don't recommend it, but you can. Our initial proof of concept was for a flooring product, like I mentioned. So like on the underside of the carpet, you'll find polyvinyl chloride. And so we did this just to show that we could. And we did this about a year or so ago. And if you see the guy in the middle, that's one of our raw materials, just so you can see how fun it is to play with, and all that is plant material. So the market size for polyvinyl chloride, I mentioned there's 40 million tons that are made annually, but in the United States alone, it is a roughly $18 billion TAM, and moving down to the building construction at a 60 to 70% rate. For PVC, it's still about 11, and that's both bottom down and top up, with about $2,000 per ton per year. And even with just the films and sheets, which I showed you we did for our proof of concept, it's about a $3 billion market. So you could tell, even in that very small market, the opportunity to create something meaningful and impactful is there. So we think our model is very unique in that, although it is a plant-based model, and you've probably heard of things like PLA and other plastics and polymers made from alternative sources, the thing that makes ours is unique is that we take plant material that is typically sent to landfills or wastewater streams, and we divert those and make our material from that. So not only are we making something that's 100% bio-based, and we are certified with that from the USDA, but also things that would fill up landfills. And as you know, landfills are meant to fail. They are going to seep things into your soil and groundwater and air just because things degrade, and that's how things are supposed to go. So we think that is unique. And part of our diversion process, we also provide data associated with ESG metrics. So as we are diverting this material away for companies, we are also able to provide them emissions data that they can use in their ESG reporting, which is really important and continues to be important, especially as people require that for investments and things of that nature. Oops, that's not me. I think we have some more slides, but they're not there. So if you have any questions, we'll see you at the outside. Thanks.
Okay, well, last but certainly not least, I'm proud to introduce Carson Crawford, the co-founder and CEO of Pike Robotics, a company that is modernizing the way that we inspect oil and gas storage wells.
So my name is Connor Crawford, but we'll go from there. All right, so I'm Connor Crawford, CEO and co-founder of Pike Robotics. Let me tell you a little bit about the work we're doing for developing advanced robotics for maintaining critical infrastructure for the energy industry. So our vision at Pike Robotics is to provide energy companies with actionable data about their infrastructure, allowing them to better plan their maintenance operations. So part of the opportunity here is we've kind of recognized an opportunity to integrate robotics into inspections of energy facilities. These jobs are traditionally done by human crews, and there are kind of three trends that we see that are setting ourselves up for success. Number one is reduction of confined space entries. Number two is rise in regulation and EPA fines. And also number three is rise in acceptance of service robotics. So kind of a little background on confined space entries. Dow Chemical, a little industry example, has set an initiative by 2025, which is coming up, to reduce injuries related to confined space entries down to 5, and they'd obviously like to get that down to 0. But there are initiatives like this that are kind of coming across the industry, and so companies are concerned now more than ever with the safety and well-being of their employees. There's also a large issue with these operators being fined for their missteps. This year, we saw a 57% increase over the fiscal year 2022 in terms of fines that violators were required to pay to the government. These companies are under increased scrutiny by federal regulators to monitor their contribution of greenhouse gases. Crowley Fuels, a few years ago, was fined $1.3 million for excessive escape of their vapors, and that was in Alaska. And normally people think Alaska is the Wild West, but you're still seeing fines all the way out there. And number three is kind of rise in investment in robotics for the energy industry. We're going to see about $28.5 billion being spent on robotics annually by 2040, and that's a 28.5% CAGR. And so these companies are turning to robotics to help them maintain their assets and also reduce their operating expenses. That's only a fraction of the $181 billion to be spent by oil and gas companies on asset integrity management. And that's a 2040 number at an 8.9% CAGR. So there's a lot of different maintenance that goes into the maintenance of these energy facilities. One particular asset that we're involved in is above ground storage tanks. And so you see you have visual, you have torque sensing, manipulation, pulsed eddy current, phased array ultrasonics, magnetic flux leakage, and sludge removal. And there are a number of companies involved with these types of inspections and these pairs. And we decided to focus on the visual and also the manipulation side of the spectrum. And that's because of some of the origins of the project, which is one of the reasons I'm here speaking to you today. Our project was funded by Phillips 66 through the Nuclear and Applied Robotics Lab here at UT Austin, right off down the road in Speedway. And so we had a sponsored research agreement, and they funded 2 projects. One was a methane localization and detection robot called PhilBART for Phillips 66. And then one was my project, which is the autonomous tank seal inspection robot, codenamed Wombat at the time. We've now changed it to Walleye. But here's some of the early prototypes that you see. And basically the objective here was to develop technologies to improve operations at their Ponca City refinery up in Oklahoma. Really, really fun town if you get a chance to go. A little sarcasm. So that gave us the second part of the vision as our mission. So we realized that adequate storage solutions are critical to meet continued demand for energy, even with all the new forms of energy being developed, with whether it's nuclear or hydrogen or other kind of decarbonized sources of energy, electric, wind. So you're still going to need these existing infrastructure, and you're going to need them now more than ever because they're not going to be building anymore. So you want to maintain these existing assets to make sure we have fuel in our vehicle to drive to work. And so our first mission at Pike Robotics is to provide a robotic platform to collect data in hazardous storage tank environments. So some of the issues with the incumbent way that these inspections are being done, well, there's a part of the tank. It's a floating roof, and these floating roofs, kind of like the way I describe it to the layperson is, it's like a French press. So if you ever made coffee, it's like a little gasket seal that floats up and down, and over time it's going to wear out just like anything mechanical. And so regular inspection is required to maintain the tank and also plan repairs. So in order to do these inspections, a lot of times you have to shut down the tank, and there can be up to $1 million average cost to drain, clean, degas, blast, and then do the inspection, and that could be a 7 to 12 week duration. You also have inspector safety and job difficulty, which is another main issue. Between 2011 and 2018, the Bureau of Labor Statistics found that there were 1,300 deaths associated with confined space entry, and a number of those were in actual storage tank interiors. It's also a very hard job to do. It's extreme temperatures. You got to carry a lot of weight on you, and we've actually gone into these tanks, and it's not a fun job to do. And as a result of the difficulty of the job, the data that you're going to collect suffers. And that's one of the reasons we saw an opportunity for robots. Robots don't really get tired. They have sensors on them that collect consistent data for the most part. And so that's kind of what we're hoping to improve is the data collection. And also, we're going to reduce fines associated with these facilities. So this is our, probably running out of time here, but this is our attempt at resolving those 3 problems that I mentioned earlier. It's an in-service wall climbing robot that is actually going to be out here. My CTO is actually setting it up out on the 5th floor where we're going to be after this. It's an in-service wall climbing robot that basically replicates and improves upon the traditional inspection process. It has a visual feed, LiDAR, physical probing, and also an optional gas detection. Some of these companies don't really want you to have a gas sensor on the robot. So, but a lot of that's changing with some new regulation from the EPA. And all this data, we collected real time and generated an inspection report where we annotate all the defects without having to send a human crew inside. This is also going to be the first robot. The inspection and everything, that's not the most sexy part about this. The cool thing about this robot is the fact that we can even operate in these flammable storage tank environments to begin with. So here's a demo of us at a fuel tank site in Waco, Texas, right up the road. Our beachhead customers are these smaller midstream and downstream marketing terminals. We received a letter of support from them, and this is a little picture of kind of the data that we collect looking at that seal. And so we generate this inspection report that we hand to the customer, and they can then, I know there was a talk earlier today yesterday about digital twins. We can populate the data about the storage tank and upload it into their software. Gecko Robotics, Hover, Kongsberg are working on this, and Hover's actually reached out to us as well as Gecko about wanting access to our data because it's really hard to collect data about that floating roof seal. And kind of get into our value proposition. No tank downtime to perform this inspection, no confined space entry by human crews. You get a high resolution quantitative inspection report, very high accuracy. Average completion time decreases by a factor of 3, and personnel required goes from 5 to 2. And also you have a large benefit per IFR tank and EFR tank, and those are the 2 different types of tanks that we do. Some of the benefits to society. Storage tanks are responsible for about 6% of methane emissions in the natural gas and oil production sector, and so we with more frequent inspections, we can help reduce that number. We're also helping improving worker safety, as I mentioned earlier, and we're also setting a precedent, which is one of the things I'm most excited about for other use cases after this, is we're setting the precedent for robot certification in these Class 1, Div 1 flammable environments. So we'll be able to move on and do other assets like hydrogen storage tanks, grain silos, and so that's where I see the future of this company. We're working on kind of a lot of the boutique inspection and repair use cases that these energy companies have. A little bit about where we've been. Started with the sponsored research agreement, went and did some surveys of storage tanks, got 2 pending patents through UT Austin, which we still need to probably pay them back for at some point. Functional tests at the Ponca City Refinery and the field tests at Waco, and also just recently did one with Chevron not too long ago. Got one lined up with Shell next month, Dow Chemical in June, and also Phillips 66 in Salt Lake City in June. We're going to have our certification by September and start having initial sales right after that. So this is our team. I'm the CEO and co-founder. Dr. Pryor, he's down in San Antonio at the Ross Industrial annual meeting, and so I couldn't be here today. But we got a good group of folks, advisors with 85 years of experience in the energy industry. Great group of contractors as well. My path to Pike, I'd kind of recommend just anyone interested in doing this entrepreneurship journey to get involved with a research lab. There's a lot of technology that just dies on the vine afterwards, so become a part of a lab, understand the technology, and then a couple years in, take a new venture creation class like I did here, a few floors above, and then just start on your journey and just be stubbornly persistent, I would just say. A little shameless plug, looking to grow the team by 1 mechanical engineer, 1 electrical engineer, and 1 business analyst, so that I can take a breather every so often. But yeah, all righty, we got a good team. That's us. We're Pike Robotics, and we're transforming inspection of energy facilities with robotics. Thank you.